Okay, let's start with lesson 10.2, solving quadratic equations by graphing, page 533 in your book. When you got a quadratic equation, you can look at it two different ways. You can look at it as a function, f of x is equal to, and this is our quadratic equation right here, ax squared bx plus c, where a is not 0. Okay, so you have to have the x squared term. If you look at that as an equation versus a function, okay, you got an equation here and a function here. So when I set x equal to 0, when I say f of x, if I want to zero it out in this equation, these two things are called related. So if I give you a function and ask you to solve its equation, that's its equation. If I give you an equation and ask you to write its function, that's its related function. So the term related function to that equation or related equation to that function. All right. When I go and solve that equation, solutions to that equation right there are called the roots of the equation or zeros. Why would it be called zeros? Well, take a look at a parabola. If I'm drawing a parabola, and it doesn't matter which one I'm drawing, but let's say that's it. That's a parabola that I've just drawn. Okay, the solutions or roots are where y is equal to 0 and it crosses the x-axis. So that's why it's called zeros. It's where y is equal to 0 and the parabola crosses the x-axis. Let's look at an example of solving via graphing. Let's say we have x squared plus 6x minus 7 is equal to 0. Okay, and that's our problem. And so we want to graph it and find out its roots or its zeros. All right, well, the first thing we do is I could just make a table and figure out how to draw my parabola. But I'm going to use the axis of symmetry equation where x is equal to negative b over 2a. Okay, that's the axis of symmetry equation. All right, well, let's take a look at my values. A, in this case, is right here, 1. B, in this case, is this positive 6. And C is negative 7. So plugging the B and the A value in, I get negative. B is 6. 2 times A is 1. So I get negative 6 over 2 equals negative 3. So what does that tell me? That tells me that when I graph this parabola, that at negative 3, 1, 2, 3, I might as well draw my dotted line. That's where the axis of symmetry is. That's where the vertex is going to be. Okay, so now I've got the left and right figured out. Now I've got to figure out the up and down. Well, let's figure out the vertex. And the vertex is figured out by taking your equation, x squared plus 6x minus 7, okay, and plugging in the negative 3. So I get negative 3 squared plus 6 times negative 3 minus 7. Negative 3 times negative 3 is positive 9, plus this is a negative 18 and a negative 7. So 9 plus a negative 18 is negative 9 minus 7. The whole thing is negative 16. So when I graph this, this would be negative 16. So let's come down here. Let's make each tick mark 5, 10. Extend this down, 15, and 20. So 16 is going to be about right there. Continue my axis of symmetry all the way down. Take my x-axis out a little bit further. Now I'm going to do my table. I'm going to pick a couple points on each side so I can draw my parabola correctly. So if x is right here, is the vertex is negative 3, negative 16, I'm going to go to the left, going this way. So negative 3, I'm going to go over 2. I just always go over 2. So negative 5 plugged into here is negative negative 5 squared plus 6 times negative 5 minus 7. Negative 5 squared is 25 minus 30 minus 7. So 25 minus 30 is minus 5, minus 7 is minus 12. And I'm going to keep going that way. 2 more, and I get negative 7 squared plus 6 times negative 7 minus 7. Okay, remember this is the chart here I'm drawing. So 49 minus 42 minus 7, that equals 0. Okay, so there's the 0. I'm going to go the other way. From this 3, I'm going to go that direction. And I'm going to go over 2. So let's go over 2 from 3. Negative 3 is 1. So when I plug negative 1 in here, I get negative 1 squared plus 6 times negative 1 minus 7. So I get 1 minus 6 minus 7. So 1 minus 6 is minus 5, minus 7 is minus 12. And come over 2 more. So I've got the 1. Here's my 1 value. And let's do that. 1 squared plus 6 times 1 minus 7. 1 plus 6 minus 7 equals 0. This one is equal to negative 12. So 1 and 0. So now I plot my points. I got the 3, 16 right here. Negative 5, 12. Negative 5, 1, 2, 3, 4, 5. And 12 would be about right here. And then set negative 7, 0. And 1, 12. And negative 1, 12 and 1, 0. And there is my parabola. Didn't draw it perfectly, but you can see right there and right there, which corresponds to this guy and this guy, are where the y equals 0, and that's where I cross the x-axis. So my solution, or my zeros to this guy, are negative 7 and 1. All right, let's go on to another example. Another example we have here is a special case. Let's make sure I got it on the page here. And it's called the double root. We'll see that, notice that if I cross the, with a parabola, if I'm crossing the x-axis, in this drawing or in this drawing here, it doesn't matter. I'm always going to have 2 places where I cross the x-axis, okay? If I cross it at all. Now, there is a special case called the double root, and that's where my vertex is right on the x-axis. So let's take the case of x squared plus 4x equals a minus 4. First thing we want to do is rearrange that equation so it's in standard form in the quadratic equation. So x squared plus 4x, and I'm going to add 4 to both sides. And that leaves me with 0 equals 0. So now I'm going to solve this and find out the zeros or the roots of this quadratic equation, or in other words, where does it cross the x-axis. So let's find our axis of symmetry. X is equal to negative b over 2 times a. Okay? So if we come here, a is equal to 1 right here. B is equal to 4 right here. And C is equal to 4 right there. So now I plug that in over here. I get negative b, which is 4, over 2 times 1, which gives me negative 4 over 2, which gives me negative 2. So, since I know that that's the axis of symmetry, I can start drawing my equation, or drawing my graph. Here's my chart, and I know that negative 2, 1, 2 is my axis of symmetry. So now I want to find my vertex. Well, the vertex is just this equation solved for the axis of symmetry. So I put this -2 inside of my equation. So my equation, x squared plus 4x plus 4 equals 0. That's this one right here. When I substitute in -2, what do I get? Okay, well, I get 4 minus 8 plus 4. Well, 4 minus 8 is -4 plus 4. That actually equals 0. So I know that my vertex point is -2, 0. So -2, 0 is right there. Okay, and finish out drawing. I make my X and Y chart. And I'm going to start at -2 and 0. And I'm going to go left 2. So I'm going to go -4 and -6. I'm going to go right, or that direction. So over 2 would give me to 0 and +2. And let's graph that. So first of all, let's substitute -4 in this equation. -4 squared plus 4 times -4 plus 4. What do we get? We get 16 minus 16 plus 4 equals 4. So that guy's 4. If we then do -6, we get -6 squared plus 4 times -6 plus 4. And we get 36 minus 24 plus 4. 36 minus 24 is 12, plus 4 is 16. So we get 16 here. And then let's finish out the other direction using 0. 0 squared plus 4 times 0. Okay, 0 plus 0 equals, plus 4. So I've got my plus 4 at the end. That equals 4. So there's the 4. And finally, do this last number in my chart. 2 squared plus 4 times 2 plus 4. And solve for that, I get 4 plus 8 plus 4. 8 and 8 is 16. So I can plot those out. -4, 4. 1, 2, 3, 4. And +4. 1, 2, 3. Let's go 1, 2, 3, 4. And then the other way would be 0, 4. Then I need -6, 16. 5, 6. -16 would be up here somewhere. And 2, 1, 2, or not -16, but +16. And there is my parabola. And my parabola crosses right there, touches the x-axis, but doesn't cross it. That's called a double root. Okay? It's poor drawing, but that should have touched. All right. That's the special case called a double root. Now let's take a look at the third case. That's the case where we don't even cross the x-axis at all, and that is an example of no real roots. Okay, in this example, number 3 in your book, our equation is x squared minus x plus 4. Okay, our a value is 1, our b value is -1, and our c value is 4. So our axis of symmetry, x equals negative b over 2a, -1, 2 times a, negative times negative is a positive, so we get a positive 1 over 2, and there is our axis of symmetry. So if I drew that out, I would look something like this. And this is 1. Let's count this as a half. So my axis of symmetry is on the 1/2 mark. Okay? Now, having said that, now I got to find the vertex. Well, once again, the vertex is taking the equation you have and setting the axis of symmetry's x value in there. So it's 1/2. So replacing x in this equation with 1/2, I get 1/2 squared minus 1/2 plus 4. 1/2 squared is 1/4 minus 1/2 plus 4. That gives me a positive value of 3 3/4. And if I were then to graph 1/2 positive 3 3/4, there's 1, 2, 3, 4. There's about 3 3/4. And now, this is a opening upwards or opening downwards parabola. Well, I look at this is positive, so it's opening upwards. So when I look at this, it looks like it is never going to touch the x-axis. All right.